Assalamu alaikum. Dear students, today we have to start the new unit, that is sets and functions. This is one of the very interesting topics of mathematics. Before proceeding towards the topic, let's have here some appreciation for the students who have given presentation on Saturday. The first name here is Siptenadi with outstanding presentation. Saman Khalid, marvelous presentation. Zainab Salim, excellent presentation. And Fatma Nadeem, superb and marvelous presentation. Moreover, here we have some appreciation for the students who have shown active participation in test. The first name here is Saman Khalid, superb. Iman Tanveer, brilliant. Abdullah Kamran, superb. Zamir Malik, brilliant. Abdul Rahman Zahid, excellent. Zainab Salim, excellent. And Azhan Shah, brilliant. Here we have our today's topic. What is set? A set is a collection of well-defined objects or things. Well-defined here means that there should not be any ambiguity or confusion. Capital letter is used to name a set. An element is an object contained in a set. For example, 2, 4, 6, and 8 are called elements of set A. Here we have some examples of set. Set of cricket playing nations. This is a well-defined set. So we can name some of the cricket playing nations as Pakistan, India, and England and Australia. Sets of oceans. Of course, this is a well-defined collection of objects, so this can be a set. Pacific, Atlantic, Indian, Southern, and Arctic oceans. If we are asked to make the set of intelligent students, so this is not a well-defined set because the definition of intelligent vary from person to person. So hence we cannot make set of intelligent students. Here we have some more examples of set. Number sets. Set of natural numbers. Of course, this is a well-defined collection of objects. So set of natural numbers can be from 1, 2, 3, 4, 5 and so on. Then we have set of whole numbers. In whole numbers we have 0 as well. Then we have set of integers which can be represented by z. Integers are those numbers which are complete in itself, which are neither in decimal nor in fraction, like -3, -2, -1, 0, 1, 2 and 3. These are the complete numbers. Then we have rational numbers. Rational numbers are those numbers which can be written in fraction form. Here we can have decimal number as well, 2.5, because it can be written in fraction form as 25 upon 10. Then we have set of real numbers. In set of real numbers, we have all those numbers which really exist, which are not imaginary. Other than imaginary numbers, all the numbers will be inclusive in real set. So hence these sets are well defined, so therefore they can be as a set. Here we have an activity 1 for you. We are going to think for a while, then state that which of the following can be written as set. Planet of our solar system, colors of rainbow, interesting books, capital cities, favorite food of children, all vowels. Of course, here planet of our solar system is a well-defined collection of objects, so this can be written as a set. Colors of rainbow is also well-defined, so this can be written as a set. If we talk about interesting books, so the interesting books vary from person to person. If some books are found interesting for me, it might not be interesting for you. So therefore, we cannot make a set of interesting books. In addition, we can make the set of capital cities because it is a well-defined. We know the capital cities of every country. Then favorite food of the children. We cannot make the list or we cannot make the set of favorite food of the children because the favorite food of a child means favorite food vary from child to child. Moreover, we can make the set of all vowels because it is well defined. So here we can say that set is the collection of well-defined objects. Okay, here we have a representation of sets. That set can be represented in three different ways. The first way is word description, or we can say descriptive method. In this method, we state the set with the help of statement or verbally. For instance, the set of even counting numbers less than 10. This set is means word descriptions is described with word descriptions. Here we have then listing method, where we list the elements of the set of even counting numbers. We can see that these are counting numbers, moreover these are evens, and even numbers, then these are less than 10. So this is the listing method. The third one is set builder notation. This method is useful when it's difficult for us to write all the entries or entries or the elements of set. So we can write the set builder notation as x. X means all the elements. It represents all the elements of a set x. This sign is such that x is an even counting number less than 10. This is set builder notation or set notation system. Here we have some operations on set you have to recognize. The first one is union of sets. The union of two sets A and B, written as A union B, is the set consisting of all the elements which are either in A or in B or in both. Let's better understand this with the help of an example. Here we have set A, B, A, whose elements are 1, 2, 4, 5, and set B, whose elements are 2, 4, 8, and 9. If we are asked to find the union of the sets, so this symbol U is used for denoting or for for union. So in union we are going to write all the elements which will be in set A as well and set B as well. I mean the combination of both the sets. 1, and we are going to write this in order: 1, then 2, then 4, then 5, then 8, and 9. Here you can observe that 2 is in set A as well and in set B as well, but it is written once. It is one of the characteristics of set that in set the elements should not be repeated. So 4 is here in set A as well and set B as well, so it is written once. If we write it once, so the purpose will be fulfilled. So therefore in set the numbers should not be, or the entries should not be repeated. We can understand it better with the help of Venn diagram. Here you can see set A 1, 2, 3, and in set B we have 3, 4, and 5. When we find the union, so we write 1, 2, and 3 is being in repetition, so it will be written just once. Then 4 and 5. In A union B, we can make it like this, and we since it will be consisting all the elements, so therefore it is colored with green. Here you have activity 2. You are going to think for a while, then you have to tell that why elements in set cannot be repeated. You can have 1 minute for this. Yeah. Here we can see that a word rainbow is written. If we are asked to write to make the set of letters in rainbow, so we can write the letters R, A, I, N, B, O, W. Here we will have the set of letters which are in the word rainbow. In addition, if we are asked to make the set of letters in infinite, so here we can say that I, N, F, I, N, I, T, E, all the letters are written. Here elements cannot be repeated. Why? We can see that here I is repeated thrice and N is repeated twice. If we see that N is the same letter in alphabet, so why to write it thrice? If we are asked to write the letters which are in set or in the word infinite, so I is one letter, so why to write it thrice? If we write it once and if we write N once, so it will fulfill the purpose. The letters which are included or which are present in the word infinite are I, N, F, T, E. So no need to write it thrice. We can write it once and the purpose will be fulfilled. So therefore the elements in the set should not be repeated twice. Here similarly we can see here the word door, DOOR. If we are asked to make the sets of letters present in door, so we can write D, then O and R. No need to write O twice. Fine. Here we have intersection of set. This is also one of the operations on sets. The intersection of two sets A and B, written as A intersection B. Here we are going to use this symbol for intersection, is the set consisting of all the common elements of A and B. In intersection of sets, we are going to find the common elements. For instance, the set in set A we have 1, 2, 3 and 4, whereas in set B we have 3, 4, 5, 6. So what will be the common elements here? Of course, 3 and 4 are present in both the sets. So A intersection will be 3 and 4. Here we can show it with the help of Venn diagram. This will be the portion which will be sharing with both these circles. This common region will be the intersection, which is in red color. Here we have set difference, another operation on sets. The difference of two sets A and B, denoted by A minus B, is the set containing those elements that are in A but not in B. We can better understand this with the help of example here. Here set A we have 4, 5, 6 and in set B we have 3, 5, 7. This is the intersection. In intersection we have the common, in union we have the combination of both the elements present in the sets A and B. If we talk about the difference of sets, so what will be the difference of sets? Okay, A minus B, you are going to write set A then set B. It means that B should be subtracted from A. A minus B means B should be subtracted from A. So you can see that what 4 and 5 5 and 5 will be subtracted. So what are the remaining elements in set A? Of course 4 and 6. So the elements which will left in set A will be A minus B. We are not going to write the elements which are left in set B because we are supposed to find A minus B. That's what if B will be subtracted from A, so what will left in A? So 4 and 6 are left in A. So A minus will be 4 and 6. Here we can understand it with the help of Venn diagram. Here you can see the set A. In set C we have 1, 2, 3, whereas in set D we have 3, 4, 5. When 3 and 3 is subtracted, so what is left in set C? It's 1 and 2. So 1 and 2, this region is colored here. So if you are going to find difference of set, so the elements which will remain in set A will be the difference of set. Now here we have complement of a set. If U is a universal set, If U is a universal set and A is a subset of U, then the complement of A is the set of those elements of U which are not contained in A and is denoted by A dash or A complement. You can understand this better with the help of example but not with the help of definition. So remember one thing, that in complement of a set we always have a universal set. So let's understand this, that what is a universal set and what will be the subset. Okay, subset is that set whose elements will be containing in the universal set. Universal set is that set which contains all the elements of the subsets of its subsets. I am again repeating my words. Universal set is that set in which contains or which have all the elements of the other sets, means the subset of this. We can better understand this with the help of example, and this example will make it clear for you. Almost everyone is familiar with the Ludo, LUD or Ludo Star. We have a dice for playing it, and that dice consists of 6 faces, 1, 2, 3, 4, 5 and 6. So just consider that dice is universal set, as a big one, means the 1 2 3 4 5 and 6. So it will be the universal set. If we throw the dice twice, so once we will get 6 and the other time we will get 5. So when you will get 6 and 5, so just make it the set B. Excuse me, set A. 6 and 5 are the elements of set A. Fine. In universal set you have 1 2 3 4 5 and 6, whereas in set A you have just 6 and 5. So if you are asked to find the complement of set A, here it is written event complement of set A, which is denoted by A dash or A complement. So how you can find A complement? Means that from universal set you are going to subtract that A, and the remaining elements will be then A complement. So if from 1 2 3 4 5 and 6 you will subtract 6 and 5, so what is left? 1 2 3 and 4. So A complement will be this. So therefore it is said that A complement, or the complement, is which are not contained in A. Fine. That those remaining which will not be in A, it will be the complement of set. Let's here we have another example. You can see here that the universal set is U, and it has the elements 1 2 3 4 5 6 7 8 9 and 10. Then you have set A here, whose elements are 2 3 5 and 7, and you are asked to find A complement. So A complement means that from U you are going to subtract A. So first you are going to write set U, which is 1 2 3 4 5 6 7 8 9 and 10, then minus sign, then set A. In set A you have 2 3 5 7. Now see that what can be subtracted. The numbers which are with the blue color, like 2 3 5 and 7, will get subtracted, because 2 minus 2 0, 3 minus 3 0, 5 minus 5 0, it will get cancelled, and 7 minus 7. So what is left? The remaining which are not in A will be A complement. So the remaining will be 1 4 6 8 9 and 10. This will be the A complement. This is all for today. Inshallah, for tomorrow we'll start the exercise. Here you have your homework. You're going to revise the topic sets and operations on set. The topics or the concepts that we learned today about sets, about the concepts of set, explanation of sets, and the operations on set. You are going to revise this by watching the video. Then tomorrow I will ask these concepts and definitions from you. So for today this is all. Have a nice day. Stay blessed. Thank you so much.